Well, hello there, kiddos. Today we're going to be learning our next lesson, which is the conclusion of our probability before we start moving into statistics, which is our graphs. For the last little bit of probability, we're going to be talking about tree diagrams, which you learned last year, and the fundamental counting principle, which is our SOL for this year. So one key vocabulary word that you have to know is sample space. What is the sample space? That's simply the set of all the possible outcomes of a probability experiment. So when we say sample space, that's all of our choices or all the things that could happen. Um, with fundamental counting principle and tree diagrams, we're not looking for specific probabilities. Fundamental counting is just looking at how many outcomes there can be. So your answer is not a fraction, it is actually a whole number. So if you look at this nice little example that we've got going on, we've got, in this box, we've got 3 different shirts. You've got a red shirt, a green shirt, and a yellow shirt. We've got 1 pair of jeans and 1 pair of shorts, and you've got a pair of tennis shoes. So if we look at that, how many different outfits could we make based on those combinations? Well, you could put your jeans with a red shirt, jeans with a green shirt, jeans with a yellow shirt, or you could put your red shirt with the shorts, your green shirt with the shorts, and your yellow shirt with the shorts, and of course your tennis shoes are with every single one. So if you count those, your total number of outcomes could be 1, 2, 3, 4, 5, 6. So your sample space is 6, or your outcomes are 6. And that's what we're going to be learning today. And it's very, very, very simple. Okay, our learning target is SOL 7.10, which we were doing with compound events, but now we're going to look at the second half, which is how we compute the number of possible outcomes using the fundamental basic counting principle. And it is very, very, very easy. Once we get going, you're going to be like, oh, really? This is a math thing? I can do this. Okay, so take out your notes. This is your first page of notes. This is page 16. We're going to review tree diagrams because they are still useful and you have to be able to recognize and read them. You don't have to be able to create them. So if you look at tree diagrams, they are used to illustrate compound probability. So what is the difference between simple and compound probability? Compound probability, remember, is 2 or more events. So it's just a graphical way that we show all of the different possible outcomes, or your sample space. The sample space is the set of all the outcomes in the probability experiment. So we've got a little probability experiment here. We're going to flip a coin, and I can't show you an actual coin, so we're going to use this electronic version. So if I start it and I hit stop, our first one that we got was, flip 1 was tails. Now let's do it again. This time we got heads. So our outcome that we got was first tails, then heads. So that is how it's compound because we have 2 separate events. We flipped the coin twice. So if I do it again, let's try one more time. This time I got heads first. Do it again. Oh, I got heads again. So this time my outcome was heads, heads. And the last one, we got tails. And let's try it one more time. We got tails. Okay, so let me move this out of the way. So with our tree diagram allows us to illustrate in a tree or a graph all the possible outcomes. So if we start, and you're going to have to write really small, here's our first flip. So flip number 1, and then we've got flip number 2. So under flip number 1, your options are heads and tails. Then from your first flip, you can get either a heads again, or you can get tails. If my first flip was tails, like it was for the first one, then I could get a heads, or like my last one, I got tails again. So then if we look at our outcomes, here's our outcomes are going to be over here. So my outcomes are heads, heads, or heads, tails, or tails, heads, or tails, tails. So how many total outcomes do I have? Well, if I were to count them, 1, 2, 3, 4. Now, if we look at our questions, what's the probability of getting tails on both flips? You'd have to look at your tree diagram to say, okay, well, here's my probability of getting 2 tails, and it would be 1 out of the 4 outcomes. So here's a specific probability where I'd say, okay, it's 1 out of 4. But that's asking for the specific probability, not the possible outcomes. And that's when you would use a tree diagram as opposed to using the fundamental counting principle. And I'll show you why in just a minute. What is the probability of getting at least 1 tail? So if we switch color, I'll do this one in green. How many of these have at least 1 tail? Well, this one has 1 tail, this one has 1 tail, and this one has 1 tail. So what is the probability of getting at least 1 tail? 3 out of the 4. The only one that doesn't give us that is the first one where you got 2 heads. Okay, so this example I'm going to let you guys do for your Edmodo quiz. We'll do the tree diagram together, but then I want you to answer the question. I'm just going to go through what it would look like. So this family has 2 children. So we have child number 1, and then you've got child 2. So they want to know what is the probability or what is the sample space of the children's genders. So they can either be male or female, or if you want to put boy, girl, that's fine too. So child 1 could be either boy or girl. Then if their first one's a boy, the second child could be another boy, or the second child could be a girl. If the first child was a girl, the second child could be a boy, or the second child could be a girl. So then, what are your outcomes? The first one is boy, boy. The second one is boy, girl. Third option is girl, boy. And the fourth option is girl, girl. And you're going to answer that question about what is the probability of the family having 2 girls, and that is going to be a fraction or a percent depending on how the question is worded. All right, we're going to skip to the bottom of page 17. So if we look at this, these are the kind of questions that you may see on your SOL. This says Jane wants some ice cream, and the ice cream shop has the above tree diagrams in the window to show the possible outcomes or combinations of ice cream that they will sell. So you can either get a cone or a cup, and then you have 2 flavors of ice cream, vanilla or chocolate, and then you have 3 options for toppings, sprinkles, nuts, or strawberries. So each one of those shows your different outcomes. So how many total outcomes are you going to have? You're going to count each one of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your total outcomes, there are 12 total outcomes. And this is the difference between regular probability, where we were finding the fraction, how many times did this happen out of how many total times. With tree diagrams, sometimes they ask for the total outcomes, which is how many total, it's your sample space. Fundamental counting principle will say how many different combinations. That's just asking for the outcomes. So if you look at number 4, how many combinations would there be if the ice cream shop added another flavor? So instead of having just 2 flavors here, we'd add a third, which means you'd have another set of 3 because you're going to split into 3 different toppings. So if you added 3 here and then 3 with the cone, that's going to add another 6. So how many would we have? We would have 12 plus 6 more. So you would have a total of 18 outcomes. How many combinations can Jane get with vanilla ice cream? So if we go back and we look, let me erase this. How many are with vanilla? Well, here's 3 with vanilla, and here's 3 with vanilla. So how many total combinations come with vanilla? That would be 6. 6 options, 6 outcomes, 6 choices. All of those go with this. And I will let you answer the last 2 for your Edmodo quiz. So you will use this page for 6 and 7 will be on your Edmodo quiz. So go ahead and do them now. If you want to, pause the video, and then or you can come back and do it when you're on your Edmodo quiz. Okay, so here's our actual SOL. And it is 1,000 times easier than the tree diagrams. So fundamental counting principle, or FCP, as I like to call it, it uses multiplication. So it uses multiplication of the number of ways each event or experiment can occur to find the total number of possible outcomes, or the sample space, and the sample space. So I want you to put a little note that with FCP, or fundamental counting principle, your answer is a whole number. So all you're going to be doing is taking the choices that you have and multiplying them together. So let's look at our first example. The Jeans Factory sells juniors jeans in different sizes and lengths. So we have sizes that we're looking at and lengths. The table shows what they have available. So here's your sizes. That's our first choice. And then our second choice gives what the lengths are. So you know, some people are shorter, so they wear petite. Some are just normal, and they wear regular. And then some people are really, really tall for their age, so they have to get those tall pants. So according to the table, how many different sizes are there? So just of sizes, if we look, we've got 3, 5, 7, 9, 11, 13, and 15. So that's 1, 2, 3, 4, 5, 6, 7. So there are 7 sizes. How many different lengths are there? For the lengths, we have 3. So to find the fundamental counting principle, all you're going to do is take your sizes times your lengths to find the total number of outcomes. So sizes was 7 times your lengths, which is 3, and so your total number of outcomes is 21. And that's as simple as it's going to get. If you take your number of choices for each one, sizes, there were 7 different choices. There are 3 different choices of lengths. You multiply them together, and that gives you your total outcomes. It's that simple. We're not even going to bother drawing the tree diagram because you don't have to know how to do it. If I were to draw it, I would have to draw 7 different lengths, and then each one's going to have 3 trees bouncing off of it. So I would get the same amount to show them. Okay. So if we look at this next example, number 1, we're at Outback Steakhouse, and you can choose from 5 steaks cooked to your liking. You have a choice of 3 different sides shown below. So here is these are the cuts of the steak, or how, which part of the cow you're eating. This is how it can be cooked. And this is your sides that you have available. So how many different steak dinners are possible? Well, we've got 1, 2, 3, 4, 5 different cuts. We've got 3 different ways of cooking it and 3 different sides. So you take your 5 choices for the first one, multiply it times your 3 ways it can be cooked and your 3 different sides, and you get 5 times 3 is 15. 15 times 3 is 45. There are 45 different outcomes or 45 different combinations that you can do. And it's that simple. Fundamental counting, FCP, 1, 2, 3. You're just going to take it, multiply it out. So if we look at the second one, Sally's Ice Cream Parlor has 5 types of ice cream. So I'm going to underline that because that's what it's telling me. There's 5 different types. It has 3 kinds of cones and 4 different toppings. So if I were taking my options that I have available, I have 5 types, 3 different kinds of cones, and 4 different toppings. Which one of these shows the way that I would do it? Would I add, then multiply? Just add. Multiply 5 times 12, or multiply 5 times 3 times 4. Well, we know because of what we just talked about, you multiply. We don't ever add. So these two are not available. Now, if you look at this, this is saying 5 times 12. Well, here's my 5. Does this equal 12? It sure does. So 5 times 12 does work, and so does 5 times 3 times 4. Okay, the last 3 you're going to do on your own for your Edmodo quiz. So again, with fundamental counting, you're just taking the different number of options, multiplying for each category, you're multiplying the number of options to find the total number of outcomes, and your answer is always, always, always a whole number. The only time that you're going to find probability written as a fraction is if they're asking for a specific event. So what is the probability of rolling a 2, or what's the probability of rolling this or spending this and getting this? Then you get specific answers, and those are written as percentages or as fractions. But for this activity, for fundamental counting principle, we're looking at how many outcomes there are, how many different choices we have, and with that you get a whole number. Don't forget to log in and do your Edmodo quiz, and make sure you have your completed notes for class.